We'll proceed in tedious calculus problem. Tedious calculus problem. As always, I say that the idea is not to solve one problem by one problem. Idea is to make anyone solve any kind of calculus problem. So that is the concept of solving tedious problem in calculus. And always we make this clear that calculus is in two parts. One is integral calculus and one is differential calculus. Integral calculus means multiplication and differential calculus means division. There can be only two parts. There is actually there are four things in computation generally people know. One is addition, one is subtraction, one is multiplication, one is division. Addition and multiplication, they fall in same bucket, whereas subtraction and division, they fall in similar bucket. So the multiplication and division, they have counterpart in calculus, and one is called integral calculus, that is actually multiple calculus, and one is differential calculus, that is actually division calculus. If you divide two items and they are independent to each other, then you can divide straightforward. X square by x is x. X square by x is x. Dx square by dx is 2x. There is difference. Why there is difference? X square by x is x. X square dx square by dx or x square by dx is 2x. One is division and one is differentiation. Differentiation or differential calculus. Differential calculus, what is difference between these two? People would say take a kind of delta x tends to 0, fx plus delta x minus fx by delta x tends to 0. No, unnecessary, not required. Okay, differential calculus means the denominator is independent and numerator is dependent. That's it. The division, any division becomes differential calculus because numerator and denominator, they are dependent. Numerator becomes dependent upon denominator. So in that sense, we cannot calculate differential. Differential means rate of change. This is also called division. Rate of change. Per unit change in denominator brings how many unit of change in numerator. Like I have given example, like keep two bags, one bag, one bag. In one bag, keep one orange. When you keep one orange, equivalently keep four mango in other bag. One orange, four mango. Try three times. How many mango are in other bag? Three times four, 12. Now, if you keep three oranges in the bag, if you keep one orange, then you have to keep four mango in another bag. One orange, four mango. One orange, four mango. Now count it. Now there are 12 mango per three orange. 12 mango per three orange. How many mangoes per orange? Then 12 by 3, that comes as 4. 4 mango per orange. 12 by 3 is same as 4 by 1. Per orange denominator. Per orange 4 mangoes. Okay, this proves that numerator and denominator are dependent on each other in the sense that mango, the number of mango is dependent upon number of oranges. Okay, if you keep one orange, then here you keep one mango. If you keep one orange, then you keep one mango. Okay, now if you keep another orange, then you keep kind of four mango. If you keep another orange, okay, then you keep nine mango. Okay, I mean, how it would be? How it would be? Okay, so something like, or let's be little bit different. If you keep, if if this bag has one orange, then that bag has one mango. If this bag has two oranges, then this bag has four mangoes. If this bag has three oranges, then this bag has nine mangoes. Something like that. If this bag has four oranges, then this bag has 16 mangoes. Okay, this proves that this bag's number of mangoes are dependent upon number of orange at this time. Again, but the equation is different. Now it is, earlier it was 4x. If there is x orange, then there will be 4x mango. How many mango per orange? 4x by x. That is 4 mango per orange. Now if it has x mango, then it has x square. If it has x orange, then it has x square mangoes. If this has x orange, then it has x square mango. How many mango per orange? How many mango? If you draw x axis, 1, 2, 3, 4, 5, 6, 7, 8. Okay, then when the orange is 1, when the orange is 1, then mango is 1. When orange is 2, at that time mango count is 4. When orange is 3, at that time mango count is 9. Orange is 4, then at that time the mango count is 16. Okay, how many mangoes per orange? Okay, that is the question. Then people would do x square by x. That will come as x. Per orange, there is x mango. Per orange, there is x mango. If you see differential calculus, then it will fall as dx square. D will be placed. Dx square by dx. That will come as 2x. Per orange, there are 2x mango. Per orange, there are 2x mango. Means at any moment, if you change one orange, then there will be 2x change in the mango. But if you go with the simple division, then if at any x, if you increase one orange, there will be x change in the mango. Let's see. Let's see. When orange is 3, I am making one change. That is 3 to 4 orange. At that time, it will switch 9 to 16. One difference brings 9 to 16, 7 changes. When x is 3, if you go by normal differentiation, it is saying the division is x, that is 3 only. At any point when x equal to 10, number of mango is 100. When x equal to 11, the number of mango is 121. Then at x equal to 10, the difference is 21. If you go by simple division, then it is say x square by x, but difference is 2x. Can you see? 21, 2x plus 1. Everywhere it is 2x plus 1. If x equal to 20, the number of mango is 400. When x equal to 21, the number of, how much? 21, 21 into 21. 21 into 1, that is 1. 21 into 22, 42. 43. 431. This is what I think so. 421 into 1, 21, 1, 2 in hand, 42 plus 2. That will come as 44, 441. When x equal to 20, number of mango is 400. When x equal to 21, number of mango is 441. Then difference is 2x. When you move one unit of the orange, when x equal to x, then the number of unit change in mango that is seen is 2x plus 1, 2x. So normal division will not work. But normal division worked in when per orange there was 4 mango. Means 4x mango per x orange. But mango is x square per x orange, then it is not work. Division is not work. Means if numerator is dependent upon denominator and it is not linear, 4x, if you draw a graph, that is a linear. That is 4x into x. When x equal to 1, it is 4. X equal to 2, it is 8. But it is a straight line. Curve, it is a slant straight line. But x square, it will be like this. So, when numerator is dependent upon denominator, then divisor will not work. Then you have to go for differential calculus. So, differential calculus is divisor, but numerator is dependent upon denominator. Denominator is independent, that is orange, and numerator is dependent, that is mango. Similarly, if I go for multiplication and one is dependent upon other, then what is dependent, that is called integrand, and what is independent, that is called differential. If I consider x is time and person is running at a speed, x is time and person is running at a speed. Now when x equal to 0, then person has a speed 0. He is not running. When x equal to 1, at that moment his speed is 1. 1 kilometer per hour. When x is 2, then his speed is 4 kilometer per hour. When x is 10, then his speed is 100 kilometer per hour. Someone would say not possible. No one can run 100 kilometer per hour. Consider he is driving a bike. Now it's possible. So this is a scenario. X-axis is time and y-axis is speed. Now he's going by a bike, motorbike, and then this is the speed. Now up to 8 hour, how much distance he has covered? That is the question. Distance covered is speed into time, velocity into time. But velocity is dependent upon time. If dependency comes into the picture, then direct multiplication will not work. Okay, if it is a straight line, the speed is like this, then no problem. But if the speed is like this, x square, then it will not work. So, dependent independent multiplication turns into integral calculus. So, instead of saying velocity into time, it will be said velocity into dt. D is introduced to specify that it is multiplication calculus. This is not norm algebraic. This is not algebraic multiplication. This is calculus multiplication. That's why d is there. Or in differentiation, dy by dx. Actually, it is y by dx, not dy by dx. Y by dx. D is placed in denominator in the front of independent component. D is placed, claiming that this is calculus. Similarly, velocity in the time is independent. In front of time, D is placed, claiming this is this is not normal multiplication, it is calculus multiplication. Anyway, this is the pro forma of the means. What I am trying to do is that person should understand the concept behind the calculus. Then only he can tackle any big thing. Otherwise, not possible. Like we are giving example. Consider I have a mass. Consider I have a mass and I want to calculate. I have a mass and I want to calculate the okay. Where is mass? Okay. Now consider that I have a 3D. Hope is it a 3D? It is really a 3D. It is a 3D. I have a 3D. I have a 3D. 3D can be like this also. This is also a 3D. This is a 3D. If this is a 3D, and I have given example, if I know the density of this, then what is the weight of this? If I know volume, if I know density, what is weight of this? Someone would say, this is a school question. Density of this is x kg per meter cube and its volume is y meter cube. Then what is its weight? X into y. If you multiply x into y, that is the kg weight of this. Now, the question is arising, what about its density is not constant, not same everywhere. Like typically, this is a fruit and it has a skin. Skin density is different, whereas inside pulp is there and seeds are. Oh, At the center, seed is there. At the center, material is different and their seed is there. Otherwise, all around the muscle of this is different and then the skin is everywhere. Density is different. If density is different, then how I can calculate weight of it? What is the formula of density? Anyone would ask. If I say density is 4 kg per meter cube, means density is constant everywhere. Then just multiply by the volume and you get the net weight. If density is variable, this is what we are in phase of calculation. Consider density is x square plus y square plus z square plus 3. Means at the origin, density is 3. But as you go around, then density will grow. Density will grow. If you reach the surface that is at radius r, consider this is a sphere. When someone reaches the surface at radius r, then density is maximum. Consider that equation. Now, if this is a sphere, then what is its weight? Then as I said, there are two candidates of the calculus. One is called multiplication and one is called division. What you want? I want multiplication. What you want? I want multiplication. What multiplication? I want I want density into volume. Okay, density into volume. What is the problem? Volume is independent and density is dependent. If it is centered at the origin, at every x comma y comma z, volume is at any x comma y comma z, there is a density. If it is centered at the origin, then at the origin there is some kind of shape like this, small spherical, and inside that seed will be there. So at the center density is different and then all along density is different. At the surface density is different. What is the equation? The equation what we have given is x square plus y square plus z square plus 3. That is the density. Density into volume is the net weight. But density is different at different volume point. At any x comma y comma z, density is something. Then another x comma y comma z, density is something else. Density is dependent upon x comma y comma z. I call it volume point. Every volume point density is different or density is function over volume. What I'm trying to do here, anyone would say this is 4-dimension problem, not 2-dimension problem. 4-dimension problem means x, y, z is independent and density is dependent. So it is 4D problem. It is not 2D problem. But I am saying there are only 2D because integral calculus works in 2D only, not in 3D, 4D, 5D. One is density and one is volume. Volume is independent and density is dependent. Okay, if that is the case, if your density is dependent upon independent volume, then what would be the weight? Density into volume is the weight. Density into, since volume is independent, density, that is capital D or small f in braces V, function over volume. FV, function over volume into D of V. Since V is independent, I place D there. D of V. Now it becomes integral calculus from volume V1 to V2. Like I gave example of a motorbike that is running at a speed. Motorbike, this is x-axis, this is origin, and this is y-axis. Motorbike is running at a speed, and then speed is x square. At any time t, its speed is t square. At time 4.5 hour, its speed is 4.5 whole square. In that sense, how much distance he has traveled up to 5.5 hours. That is integration. Okay, that is integration. But how much distance he has traveled between 2.5 hours and 4.5 hours? That is the limit. This is x-axis. The bike had started at x square. Then from the x equal to 2.5 hours and 4.5 hours, between this, if there is a graph like this, what distance he has traveled? The distance is multiplication of base and height. Means whatever is the region that is coming. I believe it is alright. Consider the bike is running like this. Consider if this is x-axis, then bike is running like this. This is x square. This is x square. If that is the case, then this is point that is 2.5, and this is the point called 4.5. In between this, if I take a straight line like this, and from here a straight line this, like this, and it hit x-axis, there will be a 2D region in between, where base is horizontal, this side is vertical, this side is vertical, but top is not horizontal. Top is like this. What is the area? That is the distance. Distance is vertical is velocity, horizontal is time. Velocity into time is the distance. But this vertical velocity is not constant at every point. In that sense, I have to calculate the area to get the pseudo multiplication of velocity and distance. So velocity and time, and that area will give the net distance. So if I'm saying from 2.5 to 4.5, then there will be limit of integration. 2.5 to 4.5 velocity dt. T is the time. Similarly here, volume V1 to V2, V1 to V2, and then density function that is x square plus y square plus z square plus 3 d of volume. Now, d of volume, if I talk in Cartesian coordinate system, then dx, x-axis, y-axis, and z-axis, they are orthogonal to each other. So I can write it as dx, dy, dz. D volume can be broken into dx, dy, dz. Doesn't look elegant. Okay, volume is x into y into z. If we talk about Cartesian coordinate system, then volume is x into y into z. Okay, d of volume is d of x, y, z. Makes sense? D of volume is d of x into y into z. D of x, y, z cube. Okay, so there are two components. One is called density and one is called volume. Volume can be represented as d of volume or d of xyz volume. If it is a surface xy plane, then it can be represented as d of xy plane. If it is a single line, then it can be represented as d of x, d of x, d of xy plane, d of xyz cube. These are single independent components. This research has to be proceeded. No one is doing research in this area where a cube can be independent component, where a surface can be independent component. Line is independent component that everyone knows. Now d of xyz cube, d of xyz cube. Now we have seen it. We have tried calculating d of xyz. Xyz cube is nothing but x into y into z as per the Cartesian coordinate system. They are multiplication to each other. In that sense, d of x, y, z, d of x into y into z can be written as dx, dy, dz. Integrand is x square plus y square plus z square plus 3. And the volume is v1 to v2. We tried solving it. If I break this volume v1 to v2, z I'll break first. And if it is a sphere, if it is a if it is a sphere, if it is a sphere, then z, if this is xy plane cutting it at the center, it is centered at the origin. The z, that is the height, and this z is minus height. This is xy plane. Then equation of z in the sphere is z equal to plus square root of a square minus x square minus y square minus square root of a square minus x square minus y square. So integration from v1 to v2, I broke it into two integration limit. One limit is x1 plane, x1 plane. Okay, so x1 area, so x1 area 1 to x1, sorry, xy, the volume v1 to v2, that is xyz1 to xyz2. I broke it into two regions. One is z1 to z2 and another is x1 y1 or xy1 to xy2. Okay, xy plane and z. Z is minus a square root of a square minus x square minus y square to square root of a square minus x square minus y square. And this xy plane is xy1 to xy2. Now, if I break xy plane again, then it will form on xy plane. If this is centered at the origin, and this is xy plane cutting it at the middle, Then on the xy plane, it will make a circle. If I see from the top, xy plane, it will make a circle. If xy plane, it makes a circle, equation of the circle is x square plus y square equal to a square. A is the radius of the sphere. Then y will go minus square root of a square minus x square to square root of a square minus x square. X will go minus a to a. So in limit region, actually x is only independent. Y is dependent on x and z is dependent upon x and y. Anyway, dxyz, d volume broke into dx into y into z. D of volume broke into d of xyz, d of xyz volume, q. Then it broke into d of x into y into z, and then it broke into dx, dy, dz, whatever it is. We saw that we cannot solve it. Okay, x square plus y square plus z square plus 3, if someone integrate with z, it becomes x square z plus y square z plus z to the power 3 by 3 plus 3. Now substitute z as minus square root of a square minus x square minus y square to square root of a square minus x square minus y square. Whatever comes, okay, it will be multiplied by 2 to the means z to the power 3 by 3. This is odd power, odd exponential, odd power. Then I can multiply it by 2. 2 I can keep outside and it becomes x square, square root of a square minus x square minus y square plus y square, square root of a square minus x square minus y square plus a square minus x square minus y square to the power 3 by 2 by 3 plus 3 square root of a square minus x square minus y square, not dy. No, it is impossible. Okay, then we took a spherical coordinate system. To a spherical coordinate system, we solved it very quickly. Now, what question arises is, we do not really have guts to solve it in a Cartesian coordinate system. Why I go for a spherical coordinate system? I can use method of substitution. Who stops us? Method of substitution that I can take. No one is stopping us, right? Method of substitution that I can do. Okay, how to go with method of substitution? What x, I can take x equal to something, and I can take y equal to something, and I can take z equal to something. Then I replace dx, dy, dz with new differentiation, and then x, y, z, I'll change it, a limit I'll change it, and make it simple. Like someone is calculating a square root of a square minus x square dx, method of substitution. Square root of a square minus x square dx. Now it will be impossible to calculate. Consider x equal to a cos theta. This is method of substitution. Then dx equal to a minus sine theta d theta. Then it becomes a sine theta. Then a minus sine theta d theta. It becomes a square minus sine square theta d theta. A square minus a square someone keep outside. Sine square theta d theta. Integration is theta by 2 minus sine 2 theta by 4. Solved, right? Okay. So now theta, someone has the limit, someone has to change into theta. If x equal to a cos theta, theta is equal to cos inverse xya. Whatever x beginning is, that theta has to be received, and whatever is the top point, theta has to be received in this fashion. Okay, so that is kind of method of substitution. Can someone not apply the method of substitution? Method of substitution can be applied only in single dimension, not in 2 dimension, 3 dimension, 4 dimension, 5 dimension, all straight, all of the way. Like consider I say x equal to a cos theta, and consider it is dx dy. Let's take 2 dimensions, dx dy. We are taking dx dy dz, or dxyz, dx into y into z, or d of xyz cube. This is we are taking. Consider this is d of xy plane, d of xy plane, d of xy plane is dx dy. Let's consider x equal to a cos theta, y equal to a sin theta, dx equal to a minus sin theta d theta, dy equal to a cos theta d theta. Now substitute there, that is wrong. Okay, that's why we talk about independent component as single, not double. This is d of xy plane, not dx into dy. That is actually wrong. Wrong. Dx dy. Okay, I can solve a dx and dy. but I have to use method of substitution only for one, not for two. Okay, then how I can solve it? Then we go for Jacobian. Let's I'm trying to modify as a method of substitution for the two dimension. This is multivariate calculus. Multivariate calculus means the calculus where we are doing dual independent component, triple independent component, 1000 independent component, but all are behaving like a single independent component. That is the trick. If I have independent component x axis and y axis together, then d of x dx dy actually it started from d of xy plane. D of xy plane I have to change into theta or something like that. Okay, so here Jacobian comes into the picture. What is Jacobian? What is d of xy plane? Earlier it was d of v, d of xy z cube, d of xy z cube. If it is d of xyz cube, I can rewrite it as d of xyz cube by d of r theta phi into d of r theta phi cube. Makes sense? Anything I can write. Multiplication. I can multiply any item, I can multiply with the item and divide by the same item as per the mathematics. So, if I have 5, I can write as 5 into y by y. Same thing. 5 into 10 by 10, 5 only. So if I have d of xyz cube, I can rewrite as d of xyz cube by d of r theta phi cube into d of r theta phi cube. Or if I talk in xy plane, then d of xy plane is same as d of xy plane by d of r theta plane into d of r theta plane. Same thing. Okay, what is d of xy plane by d of r theta plane? What is d of xy plane by d of r theta plane? What is dy by dx? If the x is independent component and y is dependent component at any point x, if there is one unit of change along x axis in x, then how many unit of change in y I see? If x, y is here and x plus 1, y is here, there is change in y. At any point x, there is a unit change along x axis, then how many unit of change I see in the y? dy by dx. At any point x, if any point x, the y is y. At any point x, if I proceed one unit, then how much y would change? How many units? dy by dx. dxy plane by d theta r plane. Means theta r means it is not talking about the length, it is talking about the area because there is two dimensions. If there is one unit of area change in theta r plane, how many unit of area it will bring change in the xy plane? dxy plane by d theta r plane. This explanation you will not get anywhere else. I guarantee upon it. Into d theta r. Okay, that is the idea. dxy plane by d theta r plane. Now consider two planes. One is theta r plane and one is xy plane. Now in xy plane, consider there is some shape and in theta r plane there is a rectangle. Okay, independent component we take as a line, rectangle, cube, not awkward shape. Because it's independent, I can take anything. Dependent component is dependent upon independent. Now consider x equal to r cos theta and y equal to r sin theta. Okay, in that sense, if theta r makes a rectangle, then as per the mapping x equal to r cos theta and y equal to r sin theta, in xy plane there will be a circle. As per the mapping I have taken, if I take x equal to 2r and y equal to 3r, 3 theta, then in r theta plane if there is a rectangle, here also there will be some kind of rectangle only. But if x equal to r cos theta and y equal to r sin theta, if there is a rectangle in xy in theta r plane, that rectangle will map into circle in xy plane. Now, if in this rectangle, if this rectangle is there, if there is a rectangle, then in this rectangle, this is rx, this is theta axis, and this is r axis, this is theta axis, this is r axis, this is theta r plane. If that is the case, then there is a rectangle here. at point R and at point theta. If I make delta, okay, this is theta and this is R. At any point theta, I make delta theta change, and at any point R, I make delta R change. Then it will contribute to change in the rectangular region, area region. Like in single dimension, I made at X, I make a delta X change or 1 unit change. Now, on the theta and theta axis, I make delta theta change. On R axis, I make delta R change. In that sense, I come to a small area change, that is delta theta into delta R. Delta theta into delta R. Now there are 2 points. One point is theta comma R. Another point is theta plus delta theta comma R plus delta R. If I make, if there is any point on theta R plane called theta comma R, then I move delta theta from theta, and this is a new point called theta plus delta theta, okay, comma R. And this point, if I go up there, it is theta comma delta theta comma R plus delta R. This area, what it is forming, this area is delta theta into delta R. Okay, so at any point theta comma R, I make a small addition of the area, that is delta theta delta R. If I see change, if I make a delta theta delta R increment in the area, delta theta delta R increment in the area, then accordingly how much increment in the area I see in the xy plane, dxy by d theta R. dxy by d theta R means at theta comma R, at theta comma R there is a rectangle. Okay, this is theta axis, this is R axis. At theta and R there is a rectangle. Accordingly, there is a circle out here. If I in this area, if I make increment of delta theta into delta R, then how much increment in this area I see? That is dxy plane by d theta R plane. In d theta R plane, whatever rectangle I have, in that rectangle, if I grow the area by delta theta into delta R, for that rectangle I had a circle in xy plane. How much circle area will grow? Dxy plane by d theta R plane. Okay, this is called Jacobian. I believe this is too much, so probably we will proceed on this. Now the point we are talking about theta comma R. Now we have x equal to function over theta R, x equal to R cos theta, means x is function over R, x equal to g is a function, g theta R, y equal to h theta R. If there is a point called theta comma R, accordingly there in xy plane we have a point called x comma y, or g theta R comma h theta R, g theta R comma h theta R, that is x comma y. If there is a, now if there is another point where we moved in theta only, so new point is theta plus delta theta comma R. Here similarly, consider this point x comma y is P. The next point P1 is G theta plus delta theta comma R comma H theta plus delta theta comma R. If I make a line, this is called PP1 line. It will be a vector, PP1 vector, and that vector is G theta plus delta theta comma R, G theta plus delta theta comma R minus G theta comma R, I vector, plus H theta plus delta theta comma R minus H theta comma R. This is one vector. Similarly, if this is P, this is P1, there will be P2, where we moved along the R. So P2, the P2 will be now G theta comma R plus delta R comma H theta plus R comma R plus delta R. P1 and P2, two vector I am receiving, because there is change in theta and there is change in R, delta theta and delta R change. This area is delta theta into delta R because it is a rectangle, but here it is some awkward shape, but we have two vectors. If I want to know the area that is changed in xy plane, I have to do cross product of these two vectors. I can get area between any two vectors if I do cross product. So P1 cross P2 is the net area change. So dxy plane by d theta r is actually P1 cross P2 divided by delta r into d theta r plane. This is the net result of dxy. Make sense? So now d of xy plane turned into P P1 cross P2, that is change in the area I see in xy plane because of change in delta r. That become like this. Now what is P1? G theta plus delta theta comma r comma h theta plus delta theta comma r. Okay, cross 1 is comma r, cross product with g theta g, I'm sorry, one is g theta plus delta theta, g theta plus delta theta comma r minus g theta comma r I vector plus h theta plus delta theta comma r minus h theta comma r j vector cross product with another one, that is g theta comma r plus delta r comma h theta comma r plus delta r. Okay, so g theta comma r plus delta r minus g theta r I plus g plus h theta comma r plus delta r minus h theta r j. Now someone has to do cross product of it and divide by delta r. Okay, that is the change in dxy by d theta r. Someone is free to do the cross. I and I cross product is not possible. I and I cross product is not possible. Anyway, just leave it. Let's just proceed. One is G theta plus delta theta comma R minus G theta R I. Okay, anyway, let's do cross product. If we are talking this much, then let's do cross product. How cross product will come? Or hope. Okay, I'm a little bit confused, so it is too much. So g theta plus delta theta comma r minus g theta r I. This is pp1. If I divide by delta theta, just I divide by delta theta, g theta plus delta theta comma r minus g theta r divide by delta theta. If I just divide it by delta theta, and one is h, this is I vector, one is h theta plus delta theta h theta plus delta theta minus h theta r j divide by, okay, whole divide by delta theta. If I see like this, then the first term, okay, then it behave like a, okay, it behave like a d by d theta, hope, something like that. I have a vector. I have a point called P. I have a point called P, and I have a point called P1. I have a point called P, and I have a point called P1. P is x comma y. That is g theta comma r comma h theta comma r. This is x comma y. P1. The P1 point is g theta plus delta theta comma r comma h theta plus delta theta comma r. If I take a vector like this, okay, now this is a vector pp1. What is dp by d theta? What is dp? If I just say what is dp by d theta, if there is a point, if there is a point called x comma y, just say what, there is a point called x comma y, there is a point called x comma y. Or if I take position vector of this, position vector, a line that is coming from origin, position is xi plus yj. If I say dp by dx, if I just say dp by dx, what it will be? dp by dx, then it will be p, it will be the position vector at x comma delta x minus position vector x plus delta x, means px comma delta x comma y. Okay, x plus delta x comma y minus x comma y by delta x. X plus delta x x plus delta x I plus yj minus xi plus yj dp by this is dp by dx. Okay, that will come as I plus dy by dxj, more or less. Anyway, if I have a point called gx plus g, I have a point called gx comma y comma hx comma y. If this point is p, then what is dp by dx or dp by d theta? Okay, I have a point called g theta. I have a point called g theta comma r comma h theta comma r, that is x comma y. If I have a point like this, what is the dp by d theta? If this is the point h, any point has Cartesian coordinate, right? X comma y. That is theta. That is g theta comma r comma h theta comma r. That is x comma y. What is dp by d theta? Okay, that will be g theta plus delta theta comma r minus g theta comma r by d theta. Okay, h theta comma theta plus delta theta comma r minus h theta comma r by d theta. I believe it makes sense. It will resolve as dp by d theta. If I have any expression like this, g theta plus delta theta comma r minus g theta comma r, okay, I plus h theta plus delta theta comma r minus h theta plus delta theta comma r. I'm sorry, I'll repeat it again. G theta plus delta theta comma r minus g theta comma r, change in theta, I vector divided by delta theta, plus g plus h theta plus delta theta comma r minus h theta comma r j by delta theta. Okay, then it will be called as dp by d theta, where p is g theta comma r h theta comma r. If I have any point called g, this is a function g theta comma r comma h theta comma r, if there is any point like that, then position vector for that point is g theta comma r I plus h theta comma r j. What is dp by d theta? Dp by d theta will be g theta plus delta theta comma r minus g theta comma r I vector divided by delta theta plus h theta comma delta theta comma r minus h theta comma r by delta theta j vector. This is dp by dt. This is what exactly we are getting. We have p1, p1 and pp2 because of theta comma r, and one point is theta plus delta theta comma r. Theta comma r, one point theta comma r plus delta r. This is what we made a delta theta r. Actual expression is dxy plane by d theta r plane. In d theta r plane, if I move delta theta delta r, that is the change in area I see rectangular, how much change in area I see in xy plane. In xy plane, accordingly, we have, if I have point theta comma r, that point is mapped at x comma y or g theta comma r comma h theta comma r. Another point is theta plus delta theta comma r, that is mapped as g theta plus delta theta comma r h theta plus delta theta comma r. This is p1, this is p. This is a vector, that is g theta plus delta theta comma r minus g theta comma r I vector plus h theta plus delta theta comma r minus h theta comma r j vector. This is pp1 cross product with pp2, that is g theta comma r plus delta r minus g theta comma r I vector plus h theta comma r plus delta r minus h theta comma r j vector whole divided by theta comma r. Delta theta delta r. Delta theta I can keep one side, delta r I can keep on other side of the cross product. Now cross product one item by delta theta, cross product to another item pp1 by delta theta cross P2 by delta r. P1 by delta theta becomes dP by d theta. dP by d theta is what I said, that is g theta plus delta theta comma r minus g theta comma r I plus h theta plus delta theta comma r minus h theta comma r j by delta theta. This is exactly it is. So it is dP by d theta cross dP by dr. So dxy plane by d theta r plane becomes dP by d theta cross dP by dr. Okay, into d theta dr plane. Now that I can write independently as d theta dr. Now net this become whatever we had dxy plane, it becomes dP by d theta cross dP by dr. Okay, someone can solve it, and then d theta dr. Accordingly, I have to settle x square plus y square plus z square plus 3 and limit accordingly. Anyway, this is 2 dimension. Now we will see 3 dimension. dxyz cube is same as dxyz cube by d theta r phi cube into d theta r phi cube. How I will resolve this? Once I resolve it, then I'll settle it down. This is method of substitution, and whatever the way we are using, this is also called Jacobian. Anyway, we had also invented in same fashion, but came to know that it is known as Jacobian. It is already done. Anyway, this is what we will see how we can proceed in 3 dimensions, where we have d of xyz cube by d of theta r phi cube into d of theta phi r cube. D of theta phi r cube numerator, later I'll break it into d theta dr d phi, considering that they are orthogonal or whatever it is. This is the method of substitution. dxyz cube by d theta r cube that I have to resolve. This full is called Jacobian. That you get in a kind of extra thing if you try to change the kind of method of substitution. Same thing happens in single dimension also. If I have dx, d of x, I can write it as d of x by d theta into d theta. This is what we are doing. D of x is same as d of x by d theta into d theta. D of dx by d theta I can calculate straightforward. X equal to a cos theta, then dx by d theta is a minus sine theta. Now it becomes a minus sine theta d theta. This is Jacobian. Jacobian is everywhere. So if I say method of substitution is Jacobian only, but dx to d theta it is straightforward. But dxy plane to d theta r plane is difficult, and it is more difficult if it dxyz cube to d theta r phi cube to d, that we will see in 3 dimensions. Then we will solve it. Please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.